Hello everyone and welcome to Lesson 8, Solving for Unknown Angles. The first thing we want to talk about is interior angles. Interior angles are on the inside of the parallel lines cut by the transversal. So in this case we are talking specifically about angles 3, 4, 5, and 6 because they're on the inside of the parallel lines. Moving on to the next thing, we're talking about exterior angles. Exterior angles are on what we call the outside of the parallel lines cut by the transversal. So we're talking about the outside angles. And in this case, they are going to be numbers 1, 2, 7, and 8. So we have interior angles and we have exterior angles. The next thing is the alternate interior angles. When we talk about alternate interior angles, we're talking about ones that are, in fact, inside the parallel lines as well as on the opposite sides of the transversal. So number 5 and number 4 are alternate interior angles. And another pair of alternate interior angles would, in fact, be 3 and 6. So 4 and 5, 3 and 6. Those are what we call alternate interior angles. So moving right along, we go to alternate exterior angles. And again, we're talking about exterior, so it's on the outside of the parallel lines, and alternate, so they're on the opposite sides of the transversal. In this case, 1 and 8 are alternate exterior angles, and also numbers 2 and 7 are alternate exterior angles. Okay, moving right along. Corresponding angles. Corresponding angles are kind of interesting. They are angles that are in the same relative position. So if you look up here, I have angle 1 that is in fact on the top left. So angle 5 is also on the top left. If I was to look at another example, I might be looking at angle 2 in this case, which is on the top right, and it goes with angle 6, which is on the top right. Changing the colors around, I could look at angle 3, and that's in the same spot as angle 7. And then the last example I'll show you would be angle 4, with angle 8. Those look similar in color, but I promise they're not. So, when we talk about corresponding angles, it's in this case 1 and 5, 2 and 6, 3 and 7, and also 4 and 8. Okay, and then in the same side interior angles, this last section here, when we're looking at same side interior, I'm talking about the following. Because we're on the interior of the parallel lines, it must be in this section. And same side, meaning that it's on the same side of the transversal. So the first example I have is 3 with 5. And another example that I have would be 4 with 6. So we're talking about 3 and 5, and also we're talking about 4 and 6. Those are what we call same side interior. So they're on the inside of the parallel lines and on the same side of the transversal. Okay, couple of important things. Alternate interior angles are congruent, corresponding angles are congruent, and the same side interior angles are supplementary. Okay, so one of the things that we have to remember this, and it looks something like this. If I had parallel lines cut by a transversal, and I filled in my initials, so for example, my initials are LM, I'm going to put an L here, an M here, and I'm going to follow around the 4 angles. And then I'm going to do it again here, LM, LM. What's interesting about this is the fact that all the L's are equal to all the L's. All the M's are equal to all the M's. And anytime I have an L plus M, it equals 180 degrees. So, for example, if I showed you something like this, and I specifically said that this angle was 120 degrees, I know this is 120, I know this is 120, and I know that this is 120. And because L plus M equals 180, I automatically know that this is 60, this would be 60, this would be 60, and this would be 60. So that's an easy way to figure out all 8 angles based on parallel lines cut by a transversal. Please copy that down somewhere. Moving on to the next slide. So in this case, it specifically talks about angle 1 being 150 degrees. So let's label angle 1 as 150 degrees. Now I happen to know that this would be 150, and that this would be 150, this would be 150, and all of my other angles, in this case, my 2, 3, 6, and 7 would all be 30 degrees. The reason for that is because several things. So for starters, angle 2 is equal to 30 degrees, and the reason would be that angles on a line are supplementary. So based on the fact that 1 and 2 are on a line, they're supplementary. Angle 3 would also be 30 degrees, and the reason I'm going to use there is that vertical angles are congruent. For number 4 being 150, I'm going to use angles on a line are supplementary. Now to jump down to number 5, we already know that number 5 is in fact 150, and the reason for that would be alternate interior angles are congruent. So think about that for a second. The relationship between 4 and 5 is that alternate interior angles are congruent. Number 6 being 30 degrees, I'm still going to use angles on a line are supplementary. And then number 7 being 30 degrees, I'm going to use vertical angles are congruent. And then number 8, also being 150. Technically, I could use alternate exterior angles are congruent going back to angle number 1 because they're alternate exterior angles. Okay, now I'm going to go to the examples on the bottom half of that page. So in this case, I'm asked what the relationship is between these angles. One of the things that I could definitely fill in is the fact that if that top angle is x minus 13, based on alternate interior angles, I also know that this is x minus 13. Then what I'm going to do is I'm going to use vertical angles, and I know that these two angles are equal to one another. So I'm going to write x minus 13 is equal to 83, and then I can solve this and get x equals 96. Now, in this next example, I happen to notice that these two angles are in fact what we call alternate interior angles. So it would be best if I was to set them equal to each other. And I would have 5x squared minus 25 is equal to 4x squared plus 75. Now, in this case, I'm going to subtract 4x squared from both sides, and I wind up with x squared minus 25 is equal to 75. I could add 25 to both sides and get x squared is equal to 100, and then I would know that x was equal to 10. So that's how I would solve that one. 2 more examples. So looking at the relationship between these two, this is what I call same side interior. So same side interior, being that they're on the same side of the transversal and on the inside of the parallel lines, I happen to know that these two angles are in fact supplementary. So x plus 40 plus 3x plus 60 equals 180. I wind up with 4x plus 100 equals 180. 4x equals 80. And x is equal to 20 in this case. If I wanted to, I could certainly plug those numbers in, and in this case, this angle would be 60 degrees, and in this case, this angle would be 120 degrees, and I know for a fact that they're correct. And now we're just moving on to the last example. So in the last example, I have this angle here. I happen to know that this angle is corresponding with this angle here. So what I'm going to do is write that in as 4x plus 5. Notice it's in the top left versus the top left. I also know that in this case, these two angles are in fact supplementary because they are angles on a line. So 4x plus 5 plus 2x minus 11 equals 180. This gives me 6x minus 6 is equal to 180. I would add 6 to both sides, and I get 6x equals 186. And then I would divide by 6, and x is equal to 31. So hopefully this makes sense, and I'll see you soon. Thanks.